Okay, so we have Magni right here, and for those of you who don't know, this is a robot with a payload of 100 kilos. I can stand on it, and many of the club have seen this already. What we have here is we have the Magni navigating. So I have set the Magni up with what we call Voice Commander, or Robot Commander. It's downloadable free from the App Store. And I can drive the robot around, but I can also give it little voice commands. I can do more than that with it. And what we see up here is, well, let me give it a voice command right now and say, set waypoint wall. Set waypoint chair. So it's accepted that waypoint name. So I'm just going to click OK. Then I'm going to drive it to somewhere else. I'm going to just drive it across the room. And as you can see, as we drive across the room, this here is RViz. So this is porting all of the ROS topics for visual display onto my laptop, which is plugged in over there. And what you're seeing is these little markers here. These, first of all, you see the camera. So this is what the robot is seeing. And then this is converting that, what the robot is seeing into things that are meaningful for the robot that's over here. So if we drive the robot over to the podium and turn it around.
You're using the teleoperation now?
I'm now using teleoperation, that's correct. So as I turn it around, you can see that it sees the little fiducials. And not only does it see the fiducials, it's marked their location. It determines where the fiducial is in three-dimensional space. So it knows where those fiducials are, knows how big they are.
It even sees a fiducial on the video.
It's even seeing a fiducial on the video, which is not a good thing because it'll confuse the algorithm. But it is seeing the fiducials, and it is projecting them onto this map here. All right. And you know, I can go and set another waypoint. Set waypoint podium. Now it's accepted that waypoint name. I'm just going to hit OK. And now what I can do is I can say, go to chair. And as you can see, the robot is autonomously now driving in the direction of the first waypoint that I just set a moment ago. And it's in fact going to collide into the chair. Just to prove that it was working, guys. Okay. And you know, of course, we can then go on and do more with this robot. So we can then say to it that you want it to go back to the other waypoint that we set. Set waypoint. No, we don't want to set a waypoint. That was a bad idea. Go to podium. And it's trying to go to the podium.
Oh, like that.
Wait,
there you go.
Did you get it to refix on the fiducials?
Well, what it actually does is it continuously updates the fiducial map, right? So, for example,
Now it's got it.
right? So, for example, I can take one of these fiducials and I can move it. And provided it can see a couple of other fiducials, it will automatically update the map. And you can see that it's done it. It's done it over here. It will automatically update the map for the moved fiducial. So if you don't screw it up too much, like insert an additional fiducial on the screen, then it will automatically update for small changes, small shifts in the fiducial frame. So yeah. So that's what we've got. We've got voice control on the robot, so that you can tell the robot to go to locations that you might want the robot to do things with. And that's all functioning. You've got RViz running on the robot, and that's being piped through to my laptop here, and it's being projected onto the screen. That's what you're seeing, and that's the entire setup that we have right now.
You mean the topics are transmitted to the node on, I mean, to
You aren't
the
running
ROS
RViz on the robot,
instance
I
over
guarantee
there.
you.
That's correct. Sorry, yes, I'm running RViz on the laptop. That's correct. So yeah.
For those of you who don't know, RViz stands for Robot Visualization. So all these acronyms.
And that's its screen over there showing you what
Actually, I think it's
visualizing.
Ross visualization, but go ahead.
Whatever. Ross stands for robot, so.
So we are publishing topics on the robot, which are being subscribed to by Ross on my laptop. It is picking up those topics, including what's being collected on the camera. It is projecting them. The robot is actually taking what's on the camera. It is reducing that to fiducials. It is making a map from it. It's also transmitting that across to the laptop.
You say making a map. Is it? I don't really see a map with borders on the RViz here.
That's right. So the map consists of these points in space and the blue lines in between them.
And the robot's location relative to those points?
Correct.
Mhm.
That's right. So it continuously scans the environment. So the only thing that's in this map at this point are the fiducials, right? So it knows the location of the fiducials in space. And when I give it a command like set waypoint chair or set waypoint podium, it localizes that point in space based on the position of the fiducials. Okay?
So do each of the fiducials become a topic? I'm starting to learn Ross.
Okay.
I know what topics are for JMS and that sort of thing, but I haven't played with it in the robot.
So we have one topic, which is fiducials, right? So what happens is that the camera takes the image, it searches that image for fiducials, and it does that continuously. Then it publishes the location of all the fiducials that it can see.
Okay, so it's a set for all of them.
Yeah, a set for all of them on a single fiducial topic. The RViz will and it gives the fiducials that it sees and their location relative to baselink, relative to the position of the robot. And so what RViz will then do is it will publish the position of baselink here, and then it will publish the position of the fiducials here. So for example, if I pick up and move the robot without driving it, you'll see that the position of baselink will move. Right? Right? So it knows that it has moved to a new location because it's seeing the fiducials, it's recorded their position in space, and therefore it can localize itself. Now this is useful, and obviously you can use it for navigation and doing point-to-point waypoint tracking, but you can also use it for other things. How many people have a robot here which sometimes, once in a while, using AMCL, loses its position in, say, the corner of a room or some ambiguous location?
When you get off into unknown space, you tend to hypertransport to different locations.
That's right. You'll tend to hypertransport to different locations. The kidnapped robot problem. And the robot will not know exactly where it is. But with this navigation stack running at the same time, all you need to do is put a fiducial up, and it will unambiguously know exactly where it is and locate itself in space. So this is kind of what we put together to try to make the problem of navigating in an open space a little bit easier.
You have to predefine the patterns for the fiducials, or it sees something that looks like one and takes that as a pattern?
That's right. So I can, for example, just before I did this talk, I shut the whole robot down, booted it up, and I didn't even load a map or set a map. I just stuck these fiducials up, and it made the map as it went along.
The fiducials come from a library where the robot understands it's number 1832, that kind of thing.
That's right.
Oh, there is a preset set of patterns for fiducials.
There's this preset set of patterns for the fiducials, but the position in space.
Okay, yeah,
is
but the actual patterns are known.
The actual pattern. Well,
the shape, that shape is known.
That shape is known. It is an Aruco marker, so there is a specification for what that is. And actually, on our robot, we have a Aruco generator, so you can generate as many Aruco markers as you would like, print them out, do whatever you want to do with them.
But does it have to be facing the marker?
Does the robot have to be facing the marker? It does have to.
The camera.
A camera has to be facing the marker. Now, obviously, for the purposes of this demo, we put the Aruco on these little stands so that you can see the Arucos and the robot can see the Aruco. And for other demos that I do, I have a front-facing camera on the robot. All right? But equally, there's a ceiling-facing mount. We would normally expect that people would want to mount these on the ceiling because it gets them out of the way. You don't have to have these nice little stands and things like that.
Connection closed.
Why is the image upside down on the left?
Because the camera's upside down, and we haven't fixed it. The default camera rotation is actually opposite to the way that we set it up, and we just haven't fixed it in software.
Any plans for like a flying version of this?
Not at this time, but we would encourage you to go in if you want to do a flying version of this. We'd encourage you. All of this software is open source. You can go to our GitHub repository. It's github.com/ubiquityrobotics. Go to the GitHub repository, download it, play with it, put it on a drone, and of course contribute back to the repository. So if you feel like that, you want to that would be a great thing to do, and we'd love it if you would work on it. It runs on a Raspberry Pi. The Raspberry Pi's relatively light, so by all means download and get the software. Yeah.
Is there a rule of thumb on how you distribute these fiducials to cover a space like this?
Yeah. So if you look at the screen, you can see that I've placed them roughly one screen width apart. And so for you to get effective navigation, you kind of want to see a couple of these in the screen at any given time, right? So ideally, you're going to place them with sufficient density that the robot can always see two of them at a time, or three. All right. Wherever it's attempting to go. So that that would mean that you put them on the ceiling and you could place them every couple of meters. Is usually pretty good.
So it's very similar to the vector span that you get. You want to be able to span the entire screen.
That's right. That's right. That's right. So absolutely. But remember that the robot is determining its pose, and you actually need pairs of fiducials in order to construct the map, because because what it will do is it will see two pairs, and then that's how it determines this map. So you can see here that this map, we've got pairs of fiducials with lines in between them, and that's what we got. So okay. So yeah, okay. Well, thanks very much, guys.